So today we're going to talk about arithmetic operators. So from math class, you can recognize addition, subtraction, multiplication, and division. These are all similar symbols to what we've been using in math class for many years. But what about this percent symbol, or when you see MOD written? Well, that stands for modulus. Although telling you what it stands for really doesn't help you figure out what it is. So let's think back to elementary school or early middle school when you were learning division. We drew this shape to do division. So let's think about a problem. Maybe I had 5 divided by 3 or 5 divided by 3. There was many ways to write it, but then I used this symbol and I said, I have 5, and I'm going to see how many times 3 goes into it. So 5 goes into 3 one time. 1 times 3 is 3. 5 minus 3 is 2. And sometimes we were even really special and we just got to write remainder or R2. Well, why did we go through this? Because modulus equals remainder. We do division and then we find the remainder. So if I wrote 5 mod 3 or 5% 3, both of these, being both modulus, would equal 2. Okay, so let's try another problem. Let's see if we really understand or get this. So what if I'm looking at another problem and it says 7 mod 9? Okay, so it means that I do the division and I see what the remainder is. So I'm doing 7 and I'm dividing by 9 and I'm going to determine the remainder. Well, how many times does 9 go into 7? Well, none. So 0 times 9 is 0. 7 minus 0 is 7. So my remainder is 7. R7. So 7 mod 9 is 7. So anytime you talk about modulus, you're going to first complete the division, and then you're going to see what the remainder is. Now, how does this work, though, when it's complicated and in an expression? So let's think about it. Say I have the expression 10 plus 12 modulus. Remember, I can use the percent symbol in some languages and MOD in other languages. 5 times 3. So we think back, we've got PEMDAS, parentheses, then I do exponents, then I do multiplication, division, addition, subtraction. Well, I can do multiplication first, it's here, but is that right? How do I know what's right? So we actually think about it. Multiplication, division, and modulus are all at the same level. So if I was to rewrite PEMDAS, I could say this was for parentheses, this was for exponents, this was for multiplication or modulus. Then I can do division, addition, and subtraction. So modulus falls in the same place as multiplication in the order of preference. So I can do 12 modulus 5. Okay? So I'm going to do 12 and I'm going to divide it by 5. So 5 goes into 12 2 times. 2 times 5 is 10. 12 minus 10 is 2, and that's my remainder. So I can rewrite this expression now that I've done this step, and I'm going to rewrite it. 10 plus 2 times 3, because we know this comes out to be 2. So the next step now would be multiplication. So I'm going to do 2 times 3. So now I can simplify my expression to 10 plus 6, and then I can finally do the addition step and get 16. So, a couple reminders what we talked about today. We talked about modulus. Modulus is another arithmetic operator. It helps you find the remainder. So first you do division, and 2, you find the remainder from that division. Also, if we have multiple operations of different arithmetic operators, modulus and multiply are all at the same precedence level. Multiply, divide, modulus, all at the same precedence level. So I hope this helped explain what modulus was, and I look forward to any questions you have.